Hello? Hello? Hello. Good evening, distinguished engineers. Can you hear me? Hello?
Hello, we can hear you.
Okay, all right.
Hello,
we can hear you, my
hear
fellow.
you.
Okay, good evening, a very warm good evening, distinguished engineers. All protocols duly, respectfully, and honorably observed. But why doing that, it will be out of order if we don't recognize some very senior engineers in our midst. Let me acknowledge the presence of Engineer Professor Beredugo. You're welcome, sir. And thank you for joining us. I can also see the president of ACEN, Engineer George Okoroma. Let me also
Thank you for recognizing me.
You're welcome, sir.
Thank you for recognizing me too. Thank you.
Past president of APWEN and past vice president of WFEO, Engineer Valerie Abueraba. You are welcome. Engineer Dr. Felicia Agubata, my own chairman, Engineer Abdumalik.
Thank you.
You are welcome. We have to hit the road running. In the course of the program, we are going to be acknowledging some of our senior colleagues when they come. Distinguished engineers, I have given a background to what we are doing in the text message. We have a group called the Engineering Society. It was actually created to bring engineers from the different disciplines of the engineering profession together for us to have a kind of cross-pollination of ideas on different areas of engineering, different issues that concern engineering and how we can offer solutions to these problems. And we started it by having interactive sections through WhatsApp. And in the course of time, it was as if the interactive session went down. I understood, quite frankly, the challenges of some of our elderly ones, because when it comes to WhatsApp, sometimes they have something to say, but typing it may be a problem before, the younger ones have the fastest fingers. So it becomes a problem, but thank God for Zoom, which is one of the, I would say, blessings of COVID, that, we can now interact and virtually speak and even see ourselves while doing that. That's why we decided to reintroduce these interactive sections so that we can be able to also use Zoom as a platform to talk about engineering, discuss some of the fundamental problems we have in the profession and how we can offer solutions to this profession. Also advise the policymakers and stakeholders alike on what to do concerning these challenges. You are all welcome once again. My name is Engineer Ben O.C. Oko. I will be directing this program for today. Today's discussion is very, very key. And why it is key is because of the topic we are going to be discussing. All of us have heard about Ajaokuta Steel. I have to give a little background of what we'll be discussing today. The federal government of Nigeria established the Nigerian Development Authority in 1971 through Decree 19 in order to advance the development of Nigerian steel industry. NSDA carried out detailed market studies and investigations on local availability of raw materials. The preliminary project report, PPR, of 1974, the detailed project report, DPR, of 1977, and the global contract of 1979 for construction of steel plant at Ajaokuta were all commissioned and executed during the NSDA period. The NSDA was thereafter dissolved through decree number 60 of 18th of September 1979. This decree also created Ajokuta Steel Company Limited, being the successor of NSDA. The Ajokuta Integrated Steel Complex was conceived and steadily developed with the vision of erecting a metallurgical process plant, engineering complex with other auxiliaries and facilities. The complex is meant to be used to generate important upstream and downstream industrial and economic activities that are critical to the diversification of our economy into an industrial one. Ajokuta Steel Plant is therefore aptly tagged as the bedrock of Nigeria's industrialization. Over 40 years down the line, the actualization of this vision seems like a mirage. Today, we shall be discussing the topic, establishing technological base in Nigeria, the Ajokuta Steel Project. Our lecturer is a very seasoned engineer. I call him a man of multiple credentials. He's an intellectual giant, a prodigious administrator. And I can also say he's an iconic personality. During his investiture, I described him also as a fashionable general and a man with a fascinating character. He's also a prolific writer, for those who know him very well. And I can round off by saying that he's also a dexterous orator. He is the first Nigerian chief project consultant on Ajokuta Steel Project from 1993 to 1994. He is the current vice president of the World Federation of African Engineering Organizations. He's also president of the West African Federation of Engineering Organizations and past president of the Nigerian Society of Engineers. He's also the Obionowu II N'Okija. Distinguished engineers, ladies and gentlemen, it's my pleasure to introduce our lecturer for this evening, His Royalty, Engineer Otis Oliver Tabubo Anyeji, Fellow of the Nigerian Society of Engineers and Fellow of the Academy of Engineering, for his lectures. Thank you very much. Please, we have rules, all of us, please, apart from the presenter, everybody should try as much as we can to mute our mics so that we don't have different audios while he's presenting his lectures. Thank you very much. Yeah, His Royalty. Over to you, sir.
Thank you, Engineer Ben Osi, the moderator. Thank you very much for putting together this group and also the event today. Distinguished Professor Yopele Beredugo, Fellow Nigerian Society of Engineers, Fellow Academy of Engineering. My landlord, Engineer George Okoroma, the president of ACEN, my boss in NDPHC, Engineer Valerie Abareba, former Vice President, World Federation of Engineering Organizations, Engineer Felicia Guabata, former President, Association of Professional Women Engineers, Engineer Abdul Malik, Chairman, Nigerian Society of Engineers, Abuja branch, and there's so many distinguished ladies and gentlemen of the highly intellectual profession or professions of engineering. I welcome you all to this presentation titled Establishing Technological Base in Nigeria, the Ajokuta Steel Project. I don't know if the moderator has the soft copy of the presentation. And if so, if we would kindly put it on for us to share. Good, so we go to the next slide. The next. Still the next. Okay, good. So now I think we should go back. Thank you. We will start our discussion this evening with a talk on technology. What is technology? And we'll find that technology is the application of scientific knowledge to the practical aims of human life, or as sometimes said, to change and manipulation of human environment. And we can visualize technology starting from the invention and development of the hand tools. And for any of us that has bothered to look at the definition of engineering, you will find that there are some close parallels between a typical definition of engineering and also definition of technology. Although technology is wider than engineering, but you'll find that from this definition that it is engineering that is really at the core of it. And objects are means of manipulating the environment, which is in the evolution of technology, with somebody is interfering. The moderator, please, can you request us to thank you. Please come back with the shared material. Thank you. So technology is just not one stream, but there are endless streams of, what would form technology. And then you have the group of technologies that have to do with materials. And that is when, of course, we begin to manipulate the environment and its contents. And therefrom, you get elastomers, you get ceramics, get glass, metallurgy, solid minerals, with their mining and processing, plastics and other materials technologies. The next slide, please. The next slide. Good. Then it evolves down to the technologies for generation of energy. For example, energy conversion, coal mining and its utilization, hydropower generation, gas to power generation, petroleum production and refining, technologies for food production also come by way of the agricultural technologies, where you have different technologies for various kinds of farming, for fishing, for beer, wine, soft drink, distilled spirits, food preservation, forestry, livestock, and poultry. These all have various technologies around them. And then the one many of us are familiar with, technologies for construction. For example, construction of bridges, buildings, canals, inland waterways, and so on and so forth. Please, the next slide. And then we have technologies for the design and manufacture of the means of transportation. And that's where aerospace comes in, airplanes, space, ships, automotive devices, ships and boats, locomotive, and so on. And then technologies for communication. For example, broadcasting, computers, information processing, photography, printing, photo engraving, and telecommunications. We also have the technologies for processes and products of other manufacturing industries. For example, adhesives, clothing and footwear, dyes, floor coverings, chemicals, paper making, soap and detergents, fertilizers, textiles, and so on. Next slide, please. And technologies for medical applications, diagnosis, therapeutics, drugs, medicines, technologies for various military applications, and technologies for organization of technological systems, for example, automation, Internet of Things, robotics, artificial intelligence. Please go on. So we want to define technological base. What do we mean by technological base? And we want to do that after having shown us about the mission or missions of technology that you see almost everything that is, every activity in existence here have, to do with some technology or the other. So when we talk of technological base, that is what enables an organization to develop new products to meet the current market needs identified by the company or country. Of course, when we say company or country, you are speaking to the fact that a well-organized corporation in the United States, for example, would have a budget that is multiples of some underdeveloped or developing countries to manufacture these products using the appropriate process technologies, to develop or adapt new product and process technologies to meet projected future needs, and to respond promptly to unexpected competitive moves or to unforeseen opportunities that require actions involving technology. And we have been familiar with some other definition that has been in use in Nigeria here since the 90s. And that is when you begin to see that technological base is almost the same thing as engineering infrastructures, which are the primary facilities required to make products which are used to set up other industries, such as power generation facilities, machine building facilities, food processing, and the rest of them. So when we are talking about that the country has to have a technological base, it is a way of also saying that the country has to develop engineering infrastructures. And you want to be able to do assessment of the technological base of a country. Again, I cite the example of the United States, where they have in the Congress what they call Office of Technology Assessment. And that office, of course, helps them to get on top of their game and, have a look ahead of what needs to be done for them to be the champions in the technology and as well economic games. And the definition that we had looked at on technological base requires that in addition to evaluating the current products, processes, and projects, the management team of a company or a country must assess whether the organization is technologically equipped to meet its strategic objectives. Further, it requires determination of whether the organization is technologically strong enough to create new opportunities for itself and to meet the opportunities and itself and threats created by its environment and its competitors. Next slide. So we look at dimensions of technological capability, and the elements for the assessment of technological base can be grouped into four: technological assets, organizational assets, external assets, projects. And each of these groups contributes to the organization's technological capability in a different way. So if we look at technological assets, these will be the most readily visible elements of the technological base. For example, machineries, equipment, factories, mines and quarries, tower cranes, etc. The set of reproducible capabilities in product, process, and support areas. Next slide. Now, organizational assets. And these are the resources that enable the business to develop and deploy the technological assets. These, the skill, profile of employees and managers, procedures of getting things done, the organizational structure, strategies that guide action, the culture that shapes shared assumptions and values. The external assets. These have to do with relations that the organization establishes with current and potential allies, rivals, suppliers, customers, and the political class. Next slide, please. And projects are the means by which technological, organizational, and external assets are both deployed and transformed. And these means should be considered as part of the technology base, insofar as the organization's modus operandi in its projects is a learned behavioral pattern that can contribute to or detract from technological and business performance. So upgrading of the technological base. We see that the base technologies are really those that are fundamental for being in the game. You must have them to be in the game. But they do not confer any competitive advantage just for possessing them, because all your competitors must have them. But it is when you are able to upgrade or uplift these base technologies with key, pacing, and emergent technologies that you can create competitive advantage and or even begin to displace the base or key technology. Next slide, please. Now, key technologies are those that can provide competitive advantage in the current game. Whereas pacing technologies are those that, while not being currently deployed, I mean, they are products from research and development, but you already see that they have proven potential of displacing one of the organization's key or even base technologies. Because when you begin the game of developing a technological base, you must also be in the game of research and development, because things will never be static. And emergent technologies are those on the horizon, presently unproven, but potentially important. That is why in the matter of research, they talk of fundamental or basic research, which is not necessarily directed at anything for the moment. And then you have applied research, which is going into solving problems that are immediate from what the activity is. So by assessing technological assets, it is very important not to have a tunnel vision of technologies the organization is currently active in, but also keep in view pacing and emergent technologies. Please. So we want to look at an example of technological base. And this is the Chinese model for electricity development, how they develop their electricity, bearing in mind that at the time the Soviet Union, which was their kind of technology godfather, when they had a disagreement and they left in the late 40s, the whole of China had only about 4,000 megawatts. And you'll see that they began immediately to work hard, because even when the Russians left, they abandoned projects that they were doing and had brought in certain equipment, and they just left it and pulled out of the country. But the Chinese pulled themselves up by the bootstraps. And between 1952 and 1962, you'll find that they established the technological base to be able to manufacture locally 72.5 megawatt generators for hydro use, 15 megawatts hydro generators, 50 megawatts high temperature, high pressure steam turbines, 230 tons per hour high temperature, high pressure steam boilers, 220 kilovolts oil-filled high tension cables. Next slide, please. And that between 1962 and 1972, they had expanded further the technology base and had the capability to produce 225 megawatt type generators for hydro use, 300 megawatt steam turbo generators with water-cooled rotor and stator, 60 megawatt hydro generators set for low head, and so on and so forth. And the above milestones were those fruits born out of a local content program. When the government is determined that in my country, I want to produce the inputs that I am going to use to give my people water, the inputs I need to produce energy from petroleum, from natural gas, from coal, from water, and various sources. I want to produce those things, those turbines that are going to be used, those transformers, those cables, those switch gears, and set a program to achieve that. That is the direction of the establishment of a technological base. And I think that what we are attempting to do here by way of local content is still a poor imitation of what is needed to really genuinely establish rapidly technological base. Next slide, please. Now, Nigeria's approach to establishment of technological base during the first, second, and third development plan of the 1960s to 1980s, the country did not have plans for the establishment of technological base for the establishment of the Nigerian economy. The nearest to that was the ancillary industries attached to Ajokuta Steel Plant and Delta Steel Plant by way of machine tools industries. Also, there was plan for the establishment of one enterprise for the manufacture of light machine tools in the country. Next slide, please. So we'll now look at Ajokuta Steel Complex, which belongs to our first discussion on the streams of technology. We talked about manipulation of the environment and its contents and the evolution of the technologies for materials development. Ajokuta Steel Complex belongs to that stream of technologies. And it is steel plant that employs the conventional blast furnace and basic oxygen furnace technology, and consists really of what we will call 4 or 5 technological colonies as follows: the raw materials preparation, coke making, iron making, the steel making shop, the rolling mills, the support facilities, and the ancillary units. You will see that the raw materials, please go back. Please go back. No, go back. Raw materials preparation, iron making, and there they have open storage, they have silos, they have separators, crushers, and sieves. Next slide. No, 6112. Go back to 6112. Please go back. Go back. Go back. No.
Should I still go? Is it forward or backwards?
Go to the next slide.
Please.
No, you're going back. You are going forward. It's 6.
Okay.
6. This
6.
is 7. Go back. Go back.
This is 6, sir.
5. 6 now. So go to the.
This one, sir.
No, you are going back. You are still going back.
Okay, this is 6.
No.
This is 6. Also, still on 6. This is 7.
Yeah.
Who's there?
No. Well, I can go on. I can go on from here.
Okay, sir.
Go on, but it would have been neater. If you get, yeah, because what we are looking for is like this, but it's under 6.
Okay.
Anyway,
this is
the issue we are trying to bring down here is that you have, after we have dealt with because we dealt with raw materials, coke making and iron making before we started having this difficulty. But after that, you are now dealing with coke making plant, where you have the coke oven plant with 900,000 tons per annum. And then the byproduct plant is really a chemical company
MSOME.
to produce the
Who's that?
Somebody is not muting his system. And benzene, and ammonium sulfate fertilizer, and so on. Then this, of course, feeds to the iron making plant where you have the sintering plant that has capacity of about 2.6 million tons per annum of 100% self-flux sinter. Then the blast furnace itself that has a capacity of 1.355 million tons per annum of iron, pig iron. And then the pig iron casting machine it has capacity for 150,000 tons per annum. And a byproduct from the blast furnace, which is 500,000 tons per annum of blast furnace slag. So that, of course, fits to the steel making, where you have LD converters and then continuous casting machines that produce the blooms that are fed to the rolling mills. Yeah, that's okay here. To the rolling mills. And you have 4 rolling mills there. The biggest one you will say is the billet mill, which receives the blooms and then makes billets. Billets that are fed to the smaller rolling mills, the wire rod mill and the light section mills. And then the medium section and structural mill, a very important plant, also is fed with blooms that they use to make these medium sections and structural parts. And that is the plant where later we will see how we have failed in this business of establishment of technological base of using this medium section and structural mill to manufacture rails. Rather, we are importing all the rails they are using for all these big projects going on, in the country. But this medium section and structural mill has the capacity to be converted to rail making. And then there are the support facilities that has captive thermal power plant, 2 by 55 megawatts, turbo blower station, air separation plant for industrial gases, aluminosilicate refractory plant, dolomite refractory plant, lime plant, laboratories, and various transport facilities by way of conveyors and other mobile transport facilities. Then we go to the ancillary units. Please go to the next page, the next slide. Now, these comprise facilities for a comprehensive repair complex for the sustenance of the steel complex. There is the building repair shop, the pattern making shop, foundry, forge shop, steel work fabrication shop, machine shop, heat treatment and hard surfacing shops, power equipment repair shop, rubberizing shop, repair shops, gantry, etc. Now, of all these colonies of engineering infrastructure, you will find that it is these ancillary units that are really what you could call technological base. These are principally machine tools facilities, and they were built just to stand by as repair shop. So when there is a problem, they will be used. So, and why was that? They were built because there wasn't sufficient engineering infrastructure or technological base in the country. If we had that all around, then there wouldn't have been need to build this and just lock them up to be waiting until something breaks down. Because this is a full machine tools complex that can be turning out products steadily. And the kind of products that you will make here are the products that you could use to build something like that at Jokuta Steel Project. And apart from these ancillary units, one of the first plants built in Ajokuta was the erection bay, what they call the erection bays, because much of the equipment and machineries that were supposed to be used in building up Ajokuta would have been too big to assemble them in the Soviet Union and transport them to Nigeria. And so they had to have some semi-knockdown arrangement for some of these equipment and machinery, ship them down to Nigeria, and then get them assembled on site. And so that erection base is like the first machine building base that was established in Nigeria. But of course, since things went haywire over there, virtually all the equipment in that base have been looted. And so the country has lost the investments that were made for this erection base. Please, let's go to the next. So we mentioned that Delta Steel also has similar machine tools base, but of course, it is a place that whose technological and support units comprise the raw materials and handling system, line plant, pellet plant, direct reduction, steel making, rolling mill, and then the ancillary facilities. So we see again a place that is so vast in terms of what you could call a technological forest that was erected using the technological base of other countries. In the first instance, in Ajokuta, we are talking of Russian technological base. And then on Delta Steel, we are talking about German and Austrian technological bases were used to do that. Now, what we are supposed to be doing is to develop our own base in Nigeria, the technology base that you could use to make the machineries, the equipment, and all the components that you need to put together to get plants similar to what you have in Delta Steel, in Jokuta Steel Plant, in Warri Refining, in Port Harcourt refineries, in NAFCON, the nitrogenous fertilizer, and so on and so forth. That has been the problem, and also what we failed in the various development plans that we have pursued in the country. And we now are forced to begin to look at how do we establish technology base. In other words, how do we establish capital goods manufacturing facilities in Nigeria? And certainly, we have the models here The models are what you have in the so-called repair complexes in Ajokuta and in Delta Steel. But taking that out of those places, the concept leads to the strategy of developing machine tools complexes that will have machine shop, foundry, pattern shop, forge shop, sheet metal cold forming, stamping, heat treatment, hard surfacing, steel fabrication, and even 3D production. Having that in, even if not in every state, for a start, in every geopolitical zone. And the reason for that, of course, is that you need to manufacture much of what you are already importing into this country in order to be able to continue to develop the engineering infrastructure you need for the different streams of technology families in the country. And also to get us begin to use what we have already established. We have not talked about the other place I mentioned where the government made effort in the development plans to say they are establishing an enterprise by name of Nigerian Machine Tools. And you will find that what they did, what the government did in Oshobo is even smaller than what they did in Ajokuta in this ancillary group. The foundry in Ajokuta is the biggest in sub-Saharan Africa. The foundry in Oshobo is just about the same capacity as the foundry in Delta Steel. The machine shop in Oshobo is also smaller than the machine shop in Ajokuta, and is really meant for smaller machines and equipment. Whereas the one in Ajokuta is meant for bigger machines, you know? So we need to push that the government makes a deliberate plan and implements it for the establishment of these machine tools complexes in the different zones, because there are products that need to be manufactured. In Nigeria, we are importing all those products, and they are all in the agricultural sector, for off-road transportation, for vehicle components industries, metal working and mining industries, food and related industries, construction, household appliances, valves for industrial use, power, telecoms, and computer fittings. In agric, for example, certainly, even for manual agriculture, you find equipment made of steel through forging, like hoes, diggers, shovels, spades, and so on. We are importing them. For animal traction equipment, traditional plows, rotary blade harrows, ring rollers, zigzag harrows, seeders and dispensers, and so on and so forth. We are importing them. Spare parts for power cultivators, wood processing machines, and so on and so forth. You need irrigation equipment, and you are buying centrifugal pumps and their components every year. Connections and vents, components for hand pumps, for sprayers. For off-road transportation, you need parts for railway cars and rail transport, bushings and covers, traction components, brake components, boat propellers, and so on and so forth. The same for vehicles, components, even though our assembly plants have slowed down, but even the little they do, they still have to import much of the components they need to make anything in the automotive area. And then you have the metalworking and mining industries and the components they need, food and related industries, construction industry itself, building yard equipment, scaffolding materials, mason tools, components for buildings, yard machines, and so on and so forth. Then in household appliances with bathtubs and other plumbing materials, valves for industrial use, gate valves for giving gas and oil pipelines and water, and compressors, rotary compressors and radial fans. You are buying these things every year, and it is easy to check it out. It is easy to take a copy of the Nigerian Trade Summary. When you look at the Nigerian Trade Summary, then you will see how much, what quantity of each of these items that we are talking about is imported to the country and at what cost. And you will see that we are the ones who actually chose not to develop, but rather to use our money to keep the industries in other countries to be sustained, not just sustained, but to also even develop further on the basis of the market we have created for them. So it is important that we champion this matter of the establishment of the technological base for Nigeria, because as a country of 200 million people, there is no way you can run such a country based on importation of all capital goods requirements and all consumable goods requirements. It is not possible. We cannot finance it. And so also we as engineers have to take special interest in this, and most especially the mechanical engineers who I believe have not done well in the past 30 years, during which they allowed their discipline to die more or less. Because when you talk about this technological base, the core of it is mechanical engineering. But we have allowed that to die in the country. And we need to see how we can revive that and resuscitate that and get Nigeria going again. So what people usually would ask is, all these things you are suggesting, how are you going to get the money? And the answer is very simple. Tell the person to go to the Nigerian Trade Summary, and you will see the amount that is being spent every year. And there is a basic principle of economic development, especially industrialization, that in a country, medium-sized country, if they import a certain quantity of capital goods or industrial products in a year, the amount you have spent to import that quantity of those products is enough to build you a factory that will produce that quantity every year. And if the enterprise is run the way such enterprises are run, it will keep producing for another 30 years before you'll have a major need of either totally revamping or replacing the place. But you would have, of course, you would have got the returns many times over before that. So the source of funds is from what we have been spending. Every year we have been spending that. So the government needs to take a decision and say, hey, I want to make these things here. And I don't also want to come to a complete halt while doing that or switching to that. maybe instead of importing 100% of what we used to import, let us import 50% and let us use 50%, the remaining 50% we will spend to begin to establish capability to make those products. And maybe in the next 3 years, 4 years, 5 years, we would have been able to establish that capability to manufacture the particular product. So that is the story about this. But the other thing we need to look at is the medium section and structural mill in Ajokuta, which I talked about earlier. In 2017, after Mr. President and Commander-in-Chief went to China with some ministers, and they came back with several memoranda of understanding on different sectors, and they were going to begin some projects that are going to be financed by China. The Nigerian Society of Engineers did advise the government that they needed to make sure that there is sufficient local content in the arrangements for the implementation of those projects that they had reached the understanding on with the Chinese. And the president responded by directing the then Minister of Power, Works and Housing, the Minister of Transportation, and the Minister of Industries to meet with the Nigerian Society of Engineers to fashion out how Nigerians can participate in those projects. Of course, we made efforts to have engagement with the ministries concerned. Only the Ministry of Industry responded in a relatively fast manner, and we began to engage with them. We met with the permanent secretary and ultimately met with the minister in charge. And the minister challenged us to come up with some projects or program that can be quickly realized. And we agreed that within 2 weeks, we should bring a proposal on that. And within 2 weeks, we brought the proposal on the reactivation, the business plan actually for the reactivation and operation of the medium section and structural mill of the Ajokuta steel plant. And because we were insistent upon impressing the government that there is need to manufacture the rails to be used for the rail projects in Nigeria. In the memoranda we prepared for the government at that time, we had explained that in a typical rail project, that about 70% of the cost of the project is on the rails. And so if you have to import the rails, that's, if we are talking of $20 billion, then ab initio upfront, 70% of $20 billion is already, offshore. Whereas the same thing can be done here. And we worked with the Ajokuta Steel Company management at that time to produce this business plan, which called for the injection of about 701 billion that will generate 809 billion profit over 10 years. That is about 80 billion profit per annum over that period. And we did also advise the government that there will be investments, including even the Chinese investments, and also the money the government already has spent on Ajokuta. When you factor all that in, of this 701 billion being looked for, the government will not need to put in more than 100 billion. And we will begin to make rail in Nigeria. That did not work because after going back and forth with the Ministry of Industry, what they did, I think in October, we started this movement with them around May or so, but in April. By October, they now wrote us to say that after careful consideration of the proposal and taking into account previous experience, that government has come to the conclusion that no part of Ajokuta Steel Complex shall be operated on piecemeal basis. That was a huge disaster, a calamity for the country. And so all these beautiful rail projects that we are doing, they're all being completed with materials coming from abroad, whereas these same materials could have been done in Nigeria. I think I just wanted to sensitize us, and particularly to urge mechanical engineers to kind of liberate us, because much of these projects are in the realm of mechanical engineering. But of course, we know that everything we do, any project that we want to do, 50% of it is civil engineering. There will be massive electrical engineering in it, instrumentation, and the rest of it. If it's a process plant, certainly 50% is civil. And then the other disciplines will come. So, but if we sit down and allow all these products that should be manufactured in our factories for things to go on like that forever, then, I mean, we are saying that we don't care if engineering thrives in Nigeria. That's what it means. So I am urging all those, our engineers, especially in the mechanical and process areas, to please get up and first, I mean, take the bull by the horn and demand for what will make this country to really exist properly. When you begin to manufacture or begin to develop a technological base, then there will be no room for all these other untoward behavior that is coming from youthful energies, because you will even be needing foreign manpower to support what Nigeria needs to do to create the engineering infrastructure that will produce what a population of 200 million people needs in all these areas that we have talked about today. So I think that I must have exceeded 30 minutes, and I apologize for that, but I will pause for now and let us have your feedback. I thank you for, and God bless you all. God bless Nigeria. God bless the Nigerian Society of Engineers. God bless Corin. God bless all our professional engineering institutions. And God bless you all. Thank you.
Thank you very much, His Royalty, Engineer Otis Anyeji, FNSC, FAIN, for this wonderful presentation. I know we have a lot of questions. We are going to be going straight into the question and answer session. Please, if you have any question, you signal by raising your hand through we have an icon where you can signal. If you click on it, I will see that your hand is raised. Then we can allow you to unmute and then ask your question. Yeah, Mr. President, sir, I want to just ask you this question so we can take it off from there. Number one, when I was doing the introduction, I did say that this project started around 1979, and the aim was to make Nigeria one of the leading industrialized countries not just in Africa, but in the world. We've moved from the Russians, we've moved to the Indians, we've had different people. We have also talked about concessioning this Ajaokuta. If you are appointed as the Minister of Mines and Steel, I think that's the ministry that is in charge of Ajaokuta, what can you do to save the huge investment we have put in this project? And again, another question I want to ask, is Ajaokuta a failed project? Can it be revived? Can it be redeemed? Again, looking at the technology of 1979 compared with the technology of 2021, do you still believe that those technologies that were used in the construction of Ajaokuta, can they still be more workable in this present generation? Thank you.
Thank you. The moderator. I think that I would rather answer the questions, not thinking of whether I will be appointed. I don't have to hold an office to try to get things done properly. And I believe that each and every one of us also has that capacity. I mean, I set up the National Automotive Council, which is now National Automotive Development and Design Council. I wasn't holding a government as such. At the time, I convinced the government to do the Center for Automotive Design and Development in Zaria, to set up the Institute of Appraisers and Cost Engineers. When I saw the problem engineers were getting into with estate surveyors and others, quantity surveyors and so on. So one doesn't have to hold a government office to. After all, those who have held it all this while have not done anything. So what we rather are urging is that all of us should see the need to make a move such that whoever is in office will do the correct thing and will do things that will serve the country, things that are sustainable. So that is, I mean, by way of that. But in terms of reviving the project was sabotaged. The project did not fail, it was sabotaged. And those who did it, those of them who are still alive have to contend with their conscience on what they did to stab their country from the back. Up till now, more than 65% of steel production in the world is still by blast furnace technology. Okay?
Yes, sir.
And the basic, the steel technology that they are using also is still being used in very many parts of the world. When I said that there is this principle of, if you notice that you are spending a certain amount to import capital goods or consumer goods into your country, that you begin to see how you can manufacture rather than import. And that if you use what you spend in 1 year to build a factory that will produce that quantity you bought in 1 year, that factory will continue to work for another 30 years. And of course, when it is working for another 30 years, there are certain rehabilitations you will do, there are revamps you have to do, there are upgrades you will have to do, there are retrofittings you have to do as technology advances. It is the same here too, that you have a blast furnace technology that was designed in the 1980s, early 80s. And things are changing, certainly. But it is not changing in that blast furnace doesn't work anymore. Things have changed in such a way that blast furnace, yes, there are certain enhancements that you can bring there that will make it work more efficiently. You know why Ajokuta, they say since 1980 something, they keep saying that Ajokuta is 98% completed. You know what that means? The 2% that has been outstanding since the late 80s have to do with some instrumentation that you cannot install until you are ready to go. That is why we have all sat down and be watching the blast furnace and everything, just idle away. So the place can run, certainly. And it needs, of course, a lot of upgrades and retrofittings of other things that have become obsolete by way of technology. And that is how people who are running some breweries, for example, if you go to Netherlands or wherever, or UK, there are some breweries that have been running since the last century. And they keep modernizing it and keep running it. And if you are to design a brewery today, you are not going to design it the way that one was designed. So it is the same here. If even we want to do the expansion, because Ajokuta was meant to go from 1.3 million tons of liquid steel to, within 5 years, 2.6 million tons. So within another 3 to 5 years, to 5.2 million tons of liquid steel. And it was to do that the same way the POSCO steel mill in Pohang in Korea was to move from 1.3 million progressively. Now, Pohang is over 20 million tons per annum. And the project started the same time as Ajokuta started. We still have not actualized our 1.3 million tons. So it is doable. It is, you can make Ajokuta run now if you want to do that. It is possible. But like we said, look at just one plant there. one plant there, the medium section and structural mill, we are saying that to rehabilitate it and upgrade it to, it has 16 strands in that medium section and structural mill. It is a 1 kilometer long plant and it has 16 strands. If you put a 17th strand, you are good to go to make rails. And we're saying if you have to do that, you have to spend about 701 billion naira. 701 billion naira, if it's 1.something billion dollars. But that over 10 years, you are going to make 809 or 810 billion naira profit. That's 80 billion a year. That's for one plant. And there are about 43 technological units in Abuja. Medium section and structural mill is just one of them. Now, the technology workable, I think I have answered that. The technology is workable because, like I said, more than 65% of steel making, iron making, and steel making in the world is still going via that process. Thank you.
Right. Thank you very much, sir. I can see Engineer Francis Tafo raising his hand. Okay, Engineer George Okoroma, let me allow Engineer George Okoroma to ask question first. President of ACEN. Engineer George Okoroma, you can unmute yourself and ask your question.
Okay. Are you hearing me?
We can hear you, sir.
Thank you very much, our Reverend Engineer, for that wonderful lecture. My question is, from the analysis you're giving, the steel industry is quite lucrative, very, very lucrative from what the last part of your answer to the question raised by OC. If this business is so lucrative, what's the role of the private sector? What is the role of the private sector in this industry? Is government policy, does it allow the private sector to get involved in the steel industry in Nigeria? And is it possible to set up a portfolio that could come in and run the steel plants in this country?
Thank you, my president and my landlord. You know, I had explained before that the government, or that there is need for 701 billion naira for the revival of the medium section and structural mill, but that the combination of public and private sector funds, if we do 30% government and 70% private, that 30% will even include the investment government already has made on the ground in the plant. 70% will have to come from the private sector. The government will not need to put in more than 100 billion. So the private sector will put in about 600 billion. That was the proposal that we made to them, you know, for private sector to run 70% and government 30% in the form of IPP. That is actually the idea for the private sector to drive.
Okay.
Thank you.
Okay, we go to Engineer Francis, can you unmute yourself? Hello.
Good evening, great engineers. Good evening, Your Highness, a fellow.
Thank you.
A very lovely presentation you given this evening to us. And on our Thursday general meeting, a senior engineer too, I'm speaking from Asaba branch, a senior engineer spoke on the Delta Steel Company. And he highlighted the same problems. My questions, I almost put down my hand because Engineer Benusi pointed out one aspect of the question I ought to have asked. And Engineer that just spoke a second perspective. It's a solution that we need. And like the topic says, it says, this is a fundamental to the development of not just our economy, to engineering in Nigeria. Why can't we have our steel mills running? I believe if, because the biggest voice, your recommendation is that engineers should rise up to our responsibilities. I think the biggest voice that will put pressure, because government has to be in support as well as the private sector from your proposal. The biggest voice to bring a solution to this problem, because we are talking of billions of naira, and not just that, advancements of engineering that would affect a lot of professionals. The biggest voice ought to be NSC. Can NSC, in Nigerian Society of Engineers, take this as top priority? I don't think there's going to be a bigger voice in the country than the Nigerian Society of Engineers, because all of our fellows, all our senior engineers who have a first-hand experience of this moribund state of our steel companies now, appreciate the problem. Can we champion this cause? The elders that we have using our front, NSE, to get a solution to this problem. Sir. It's not just putting you on the seat as a minister. Yeah, just can we use NSC now, not like as a politician or as the president of Nigeria? Can we use NSC to solve this problem, sir?
Well, you know, I told you that in 2017, we as NSC approached the president immediately. He came back from China. And we said, all the memorandum of understanding and agreements they reached, that this will not really work if Nigerians are not participating in at all levels of the project stuff. But of course, you know what some of our ministers were saying at the time. Some were saying railway technology is too much for Nigerian engineers. Some were saying that the Chinese are going to provide the money, and therefore, is anything they say, oh, we must do. And these are certainly not how things are done anywhere. If you're taking a loan from people, it is still your money. In fact, you're going to pay much more than what you are taking. And so you certainly have a voice in how things are going to be done, in even saying what you want. The person giving you loan, the person coming to do your contract is supposed to do what you want. It's not you just watching and then he's doing what he wants, and when he finishes it, you'll find that it is not suitable for you. So NSC at least made its voice heard on all the sent memoranda at the time. And I think that what can happen is just that maybe we should continue again. We should still continue to demand that things, that the right things are done and that things are done right.
Exactly, sir. Persistence.
You cannot come to a country of 200 million people here and very brilliant people. Nigerians are naturally intelligent, some positively and some negatively. But you'll find that many of the projects that we're embarking on now, if Nigerians were manufacturing the things they are using to do these projects and transporting them and doing activities on the entire value chain of each of those sectors. Look, you cannot have young people idle in this country. That's one. And so the piece you are looking for, it is this technological base that is going to give it to you. Because you would have opened up a lot of opportunities that will tend to upgrade the lifestyle of virtually all the population. But we are not doing that. It doesn't mean anything to us that we are spending 20 billion and 14 billion of it, we're using it to go to buy things from factories in other places, whereas we have such factories here. And it is until, people keep shouting. Look, there are many times the government has wanted to do something, and then some people shout, they write, they go to television and so on, and the government changes its mind. We have not made the right level of noise that you need to get government to at least have our attention, listen to us, take our advice, and begin to go on the right direction.
Exactly, sir.
We have not made that level of noise. And we are seeing others making noise on even less important things. And the government is listening to them and, bending to, work with their advice. So I still challenge, because this thing we are talking about is basic responsibility of mechanical engineers. And yet you can tell that in this country, mechanical engineer is almost gone. And yet they are the ones who are supposed to be doing all these things, all these technology base of a thing. They are the ones that are supposed to be forefront of it.
Okay, all right. Thank you, sir. Let's take a question from Betala. Engineer Batella, please, can you unmute yourself and ask your question? After that, we take from Engineer Robbie James Weavery. We are running out of time. We're supposed to end by 5:30. Let's take these two questions and then wrap it up.
Okay. Thank you very much for this wonderful presentation from our past president. Indeed, it's a timely, this presentation. And the challenge is before us as an engineer, for us to look inward. Some of the questions I wish to ask, our distinguished president has make it very clear. Like, for example, inviting the engineers to also take the bull by the horn in collaboration with the government. Of course, we have very intelligent engineers in the country, but the opportunity for them to practice is very difficult. So the NSC should, my own kind suggestion is NSC should look for the collaboration with the government. And we also need to know that the competence always breed competence. And with the caliber of the people we have that have very expertise in such an area, I hope once if we involve those people, we can see the light of the day. Thank you very much. My one is common.
Okay, let me allow Engineer Robbie James Weavery to ask his question. Then his royalty will now wrap it up.
Thank you.
Engineer James Weavery.
Yes, my comrade, thank you very much. Good evening, Your Royal Highness, and everyone that is listening to this evening. I must thank you, Your Royal Highness, for that very educative lecture. I am glad I'm part of this evening. No doubt, the steel sector is a highly lucrative venture. My feeling is that the government is aware of the benefits of this huge investment. But the question is, why is government developing coal fields in exploring these opportunities provided by the steel sector? I feel it may not be far away from the fact that the returns on this investment is not immediate. So the challenge is, how do we convince those in government to look beyond immediate gains that is expected from such investments? Thank you, Your Highness.
Thank you very much, sir. His Royal, I hand over to you, sir.
Well, thank you. Let me just start with the distinguished engineer Weavery, past President, Chairman Nice. The government is, of course, developing coal fields in taking advantage of the huge benefits there are in having a local steel sector. Well, I don't know if we will say that the gains are not immediate. If it is gains for the gains for the country are immediate. But if it is gains for rent seeking and stuff like that, then of course, it will not be immediate, because if it becomes immediate, then this other one, the main thing, will not even work. So it is, the government need to be engaged with explaining to them that what we are talking about is that they should look at their expenditure profile. The government is buying steel every year. I mean, certainly if Abuja is developing and expanding, people are buying steel to do all these things, both public and private. And if Engineer Weavery is importing steel from Taiwan, it is the government of Nigeria that is importing it. He has to get certain approvals and so on and so forth before he's able to transfer money and do all that and bring it in. So both the public expenditures and the private expenditures on bringing steel in from other countries, these are monies spent by Nigeria. And what we are saying is that the investment is not, you are not going to the cloud to conjure this investment to come. No, you are going to take it from your expenditure profile. Because this year, this is 2021, the government is buying steel from foreign markets. Next year, they will still continue to do it until they begin to produce here. So it is necessary that the Nigerian Society of Engineers, especially with the professional engineering institutions, NSC has at least about 26 or so of these institutions. And each one has a sector that it is attached to, or sectors that it is attached to. NSC working with them should be able to make the right level of noise that the government will, find difficult to just ignore, and begin to spend differently. That's what we are saying. this same budget they make now, this same budget that is current, you take it, you restructure it, you look at it, and
hello, can you hear me?
We can hear you.
I think his royalty has gone.
Maybe he has problem with his network or power failure. What is that?
His time is up now.
Yeah, okay. I think let's just give him like 1 minute to come back so we can thank him and wrap it up for today. I can still see him online. I think it is a little network or power challenge.
Meanwhile, can I say something?
While we are waiting for him, let me quickly acknowledge the very senior engineers and all engineers who joined for this lecture. Engineer Joe Samuel, Engineer Anselm.
God bless you.
You're welcome, sir. Engineer, oh, I can see my Deputy President, Engineer TSG Woodale.
Thank you, Ben Osi.
My Oga, I'm lawyer, sir. And I can see, sir?
For those of us who have been working with his royalty, we know his encyclopedia of
yes, sir,
engineering practice, engineering theory, and engineering professional activities in Nigeria. So we are not expecting anything less than what he has given us, but we always learn every day. So that is why I came in quietly and tapped what I wanted to tap and took my notes in anticipation of some 12 months to come.
Thank you very much, my DP. You're welcome, sir.
Thank you.
Also, I can see Engineer Chris Eguatu, Engineer Michela, Engineer Dawood, Kelani. You're welcome. And of course, my guy, Engineer Dr. Wei Senali, Engineer Egu is also here, and Engineer Dennis Dania, my chairman. You're welcome, sir. I can also see Engineer George Opanachi, my chair. You're welcome. Another senior engineer, Engineer James Samiang. You're welcome, sir. Engineer Emo Ibrahim, a very senior engineer. You are welcome. Engineer M.T. Bauer. Engineer Ewaka Akonde. I can see you are welcome. Engineer H. Ibrahim. Engineer Habib Abubakar Sani. Engineer Wadike Jones. Engineer S.S. Nyan. Engineer Etafu. You have made comments, and also Engineer, my president, Engineer Felicia Nena Agobata. You're welcome. I can also see Engineer Gudabia. My friend, Engineer Gudabia, it's been a long time. You're welcome. I can also see Engineer Olu Kenol. You're welcome, sir.
Thank you, Ben Oslin. Thank you, Ben Oslin.
And Engineer Surajo.
Thank you, Ben.
Suleiman. Engineer Udemezue Ikechukwu. And our father in the house, Engineer Beredugo. I can also see Engineer Valerie Abwerawa is still with us. You are all welcome.
Thank you.
Thank you, Ben.
If I did not call your name, if I did not acknowledge your presence, you are duly welcome. Can I also see Engineer Abdulmalik Abdul Bari, my chairman and lawyer, sir? You are welcome. I think his royalty is back. Let's allow him to wrap up so that we can end in the next 2 minutes. We should be wrapping up the program. You are royalty, sir.
Well, thank you, and accept my apologies for The break in transmission.
It was due to power.
The next question was from Engineer Batula, or Batala. And
yes,
that was really more of a comment
yes,
about NSC collaboration with the government to see whether we can pull this through and the government begins to take this matter of a technological base seriously. I think one way of doing that is that at the end of this, the organizers will have to put up a report and package that report to the leadership of the Nigerian Society of Engineers and request that the society takes up this issue and similar other issues, because I'm sure a lot of us know other things that are going on in this country whereby we have factories that are lying fallow and we are importing the products that could easily be realized from such factories. It is certainly engineers that will benefit if manufacturing commences in Nigeria in a sustainable manner. That is the gain of engineers, all disciplines of engineering. And so I endorse that suggestion of Engineer Mutala and suggest to organizers of this forum that at the end of this, and also subsequent discussions you make a report that can be presented to different levels of authority. So I think with that, I'm done with the two questions that I got from Engineer Weavery and Engineer Batala.
Thank you very much, His Royalty, Engineer Otis Anyeji, for this wonderful presentation you've done. We want to sincerely appreciate you for making our time, despite the short notice, to come and do this presentation. It's my pleasure, since we have the Deputy President of the Nigerian Society of Engineers here, Engineer TSG Wudil. It's my pleasure to invite Engineer Wudil, so Engineer Wudil can give us vote of thanks on behalf of the people who have attended this forum, this lecture this evening, and then we wrap it up for today. Next month will be another beautiful month for us. I don't want to let the cat out of the bag, but it's going to be on another very serious topical issue, just like the Ajokuta steel industry that we have been trying for many years to fix in the country. And the person who will be giving the lecture is somebody who is also in the middle of it. So get ready for the month of March. It's going to be an explosive one. My Deputy President, sir, it's my pleasure to hand over to you.
Thank you very much, Ben. You are His Royalty, Engineer Otis Anyeji, FNSE Fellow of the Academy. We thank you very much for sharing your vast knowledge on the steel industry in Nigeria. We know, as I said before, you were offline. I served you right when you were vice president and up to the time you became president. And I know who you are. And there is no moment anybody that will spend with you will not learn something, either in engineering design, engineering research, name it. I remember the first time I came to your office, you took me to the library, and I said, wow, some universities do not have libraries like this. So that shows you have so much resources to give to the society. And your presentation is nothing less than what we expected. And we pray God will continue to give you good health and wisdom so that we keep tapping from you. So that at least we'll also give back to others. And I'm sure anybody who has attended this is just like training the trainer. So your suggestions to the Nigerian Society of Engineers, we are ready to receive it. And it will interest you to know that early last year, the president mandated me to represent him on a courtesy visit to the Minister of Solid Minerals. And it came after consultation with the management of Ajakuta Steel. And we still know there are some serious political problems that need the input of NSE to break the jinx. And we will engage you more on that, I assure you. We will do that, and your suggestions and proposals will be put forward before the president, and definitely we are going to work on it. So on behalf of all the participants, we thank you very much, sir, and pray God will continue to keep you safe and healthy for us. Thank you. Good night.
Thank you very much, Mr. President-elect and Deputy President of Nigerian Society of Engineers, Engineer TSG Wudil. In fact, I was telling somebody that I needed to speak with you on some sensitive issues. And
no problem, sir. Once I'm out of isolation, I'll meet you.
It's all right. It seems I'm your senior in isolation.
Is it prison?
It's nice. It's nice. Status symbol.
Yes.
Thank God for successful isolation.
Yes, sir. Yes, sir.
President.
Yes.
Okay.
All right, sir.
Anytime you please let me know.
Bye, everyone.
Okay, sir. Okay, sir.
All right, thank you. Thank you very much, everyone, and do have a very wonderful weekend. Once again, my name is Engineer Ben O.C. Oko. It's my pleasure to sign out.
Thank you, everyone.
Thank you, Engineer Ben O.C. Oko, FNSC.
Thank you very much. Thank you.
Thank you.
Thank you, everyone.
Bye-bye.
Thank you. Bye.